so this picks up with section 1.5, and we're going to continue from here. And so we have a reminder, we have parallel lines, and what do we know about parallel lines? In specific, they have the same slope. Good. And the next thing we're going to look at is the perpendicular lines, which have opposite reciprocal. Now, what do we mean by opposite reciprocal? So if my given slope is 2, the opposite reciprocal of that would be what? Opposite, and the reciprocal of that would be 1/2. So that's what we mean by opposite reciprocal. Okay. Given the conditions to write an equation in the indicated form. So now we're going to be given certain things. We're given a point, passing through a point, and parallel to the line whose equation is. So we're given an equation, and what we want to know about this is parallel to this equation. Well, all we care about in that equation that is given is the what? The slope. That is in slope-intercept form. So what is the slope in this particular equation? -2. So that means we're going to be using parallel to that. So we want to use our slope is -2 because we want to use the same slope. And now we're left with, we have a point and we have a slope. So what do you think we'll start with? What format? We'll put that in point slope form, and then in the end we know we're going to slope intercept. So the first thing we're going to do is start with point slope. Erase. So that's going to be, always write your formula, y minus y1 equals m x minus x1. Okay. So y minus y1 is a -3, so it just gives us y plus 3. Our slope, because we're using parallel, we want to use the same slope, -2, and then minus x. So this is actually point slope form, but they ask us to go to the slope-intercept form. So now we're going to solve this thing for y equals, because slope-intercept is y equals mx plus b. So and then I'm going to try to squeeze this in, but subtract 3 from both sides. So we get y is equal to -2x plus 5. Okay, by default, what do you notice about this by chance? And it ended up being what? The same as the equation I had given, which is not usually what we do when we're working out these problems, but I'd like to use it as an example. What does that mean? What can that tell us? What can that tell us? So to sum that up, basically, by a random chance, this particular point actually was a point that was on this line, and that usually doesn't happen much, but I left that be just a good teaching point, and we'll see some more examples where that's usually not the case. So let's look at number 9. We're going to use another one that's similar to it. We're given a particular point. They want perpendicular, and this is the given line, given equation. So the first thing we need to do is, from the given equation, we need to determine the slope. So let's solve for y and put this in slope-intercept form. So if I add 8x to both sides, that would give me y is equal to 8x plus 5. Move 8x to the other side and move this 5 to the other side for solving equations. So now I can look at this and say the slope that they gave me of the given equation is going to be 8. But what I need to use is perpendicular to that. So what is perpendicular to a slope that's 8? Negative 1/8. Opposite, and then the reciprocal. So this is the slope I want to use for my equation, and this is the point. So once again, we're going to use point slope because we're given a point and we have a slope. Y minus y1 equals m x minus x1, and we want to plug those values in. Okay, and then we want, this is our point slope form, and then after that we want to put it back in slope intercept because that's where we're going with it. You can distribute this out over here and work with fractions, or there's also another thing we can do to try to avoid fractions, and I'll do that example out to the side. As a side note, if we want to get rid of the fractions, we can see that the denominator is an 8. So if I multiply each term by 8, and this entire side, this side is completely connected, so it's multiplied. So then here I'm just going to get 8 times y minus 40 is equal to, now this 8 will cancel with this 8, and I'll just distribute this negative 1. And then now you can see we don't have a lot of fractions at this point. We don't have any fractions at this point, and we can solve for y. And then divide both sides by 8. Simplify any fractions that can be simplified. So we get y equals negative 1/8x plus, I think we could divide a 2 out of each of those, so reduce to this. So this is our slope-intercept equation. And here's just an extra example if you want to pause at this time and just get some practice doing that and then checking your work. Now we're given, it says find the slope and then describe what it means in terms of rate of change. So we have the linear function f of x, this is in function notation, is equal to 3.9x plus 20. And that represents the percentage of people who graduated from college so many years after 1998. So when we look at this, the first thing we want to do is determine what is the slope. There. Okay, good. So the slope is 3.9. Okay, that means the rate of change is 3.9. It's and what can we imply about that in respect to the given information? What about the number of people that graduated? What can we imply about that? If the slope, which is the steepness of a line, is going to be 3.9, we can say that the people graduating increased, yes. Okay, so here we want to look at the average rate of change of a function from x1 to x2, and we're given the change in y, that delta y is notation for change in y over change in x. Now we looked at this before as y2 minus y1 over x2 minus x1. Slope, that looks familiar to you? Well, let's just look. That's still the change in y over the change in x. So this is a different notation for that. Because we're looking at functions and we were given a function notation here, we're going to see that formula in this format. And we want to recall that we said we're going to be writing things in function notation, and I want you to be familiar with seeing this. Y is the same thing as f of x, or y equals f of x here. Now, if I'm trying to transition from this type of notation to a function notation, I want you to follow with me. If y is equal to f of x, then you can see this is the same thing as y2 minus y1 over x2 minus x1. So it's very similar and it aligns in that manner. So now we want to be able to solve a problem with these values. Okay, let's write this. So f of x is the square root of 2x. This is given just from this part right here. Okay, and we want to be able to evaluate that from when x sub 1 is 2 and x sub 2 is 8. So if I do the function evaluated at x sub 1, it would just be everywhere there is an x, I'm going to plug in this value right here. So in this particular case, when I plug in x sub 1, I'm plugging in 2 from this information here. Okay, and then we're going to actually just calculate that. What is 2 times 2 is the square root of 4, and the square root of 4 is simply 2. Good. Now let's just do all our calculations, evaluate all of our functions first, and then we'll plug them back in. The next one we want to do is x sub 2. So I write that this time in place of x, I'm going to plug in x sub 2. So I'll look up here, and x sub 2 is equal to 8. So then we're going to simplify this. 2 times 8 is 16, so we're looking at square root of 16, which is 4. So now I have the values for my function evaluated at x sub 1 and my function evaluated at x sub 2. We want to come back up here and plug it into our formula. So the function evaluated at x sub 2 equals what? 4. Good. What is the function evaluated at x sub 1? 2. Then what is our x sub 2? It was given 8. And what is our x sub 1? It was simply given 2. And then we simplify this. 4 minus 2 is just 2 over 6, which simplifies to 1/3. And here is an extra example if you want to pause the video and practice.